Sir, for iodine, sir, the E naught of it is 0.54 or 1.54. Sir, no, here.
My mic was, I just realized the mic was on mute. Sorry about that. All right. Right. So I was asking, before we answer this question, can you just remind us what is oxidation and reduction in terms of electrons?
Oxidation is the loss of electrons. Reduction is the gain of electrons.
Right. What would happen to an oxidizing agent?
It will lose electrons and its oxidation number will increase.
In terms of oxidation and reduction, oxidizing
It would
agents
be
are
reduced.
right. The oxidizing agents are always reduced. Now, what these numbers are showing you is the tendency of the halogen to actually accept electron. So the more positive the number is, the better it is at accepting electrons, right? The question says, use the inert values on the sodium sulfate reagent, explain the reactiveness of halogens. So if it is able to accept electrons readily, it's going to be more reactive. So the better an oxidizing agent, the more reactive it is. So again, these values are telling you how easily it accepts electrons. And if it accepts electrons, it is going to be reduced, making it an oxidizing agent. So based on that, which of these elements would be the most reactive?
Fluorine.
That is correct, because it has the highest E naught value. Tine it in with sodium thiosulfate, there's a reaction between them and the sodium thiosulfate. I will do the equation afterwards. So answer this question, right? We need to mention that the higher the E naught value, the greater the tendency of the element to be reduced, is to accept an electron. All right, so if I'm answering this, I would state the E naught. State the E naught of each element to start out with. The E naught for thiosulfate is positive 0.09. So what this is saying, right? Since as the E naught for thiosulfate is lower than all of these, it means that all of these will gain electrons from thiosulfate. So the thiosulfate would be oxidized and these would be reduced. So positive 0.9 compared to all of this, the thiosulfate would have a greater tendency to give up electrons compared to these. Could you please repeat? All right. So we are using the E naught values here and the sodium thiosulfate explain the reactiveness. I'm saying even though we don't know the redox equilibria yet, the more positive these numbers are, the better they are at giving up electrons. So when you did electrochemistry, which is redox equilibria, you would realize like reactive metals such as zinc, they have a negative E naught value, meaning they tend to give up electrons rather than accept it. So all of these will accept electrons from sulfate because it has a lower E naught, but fluorine will do it the best because it has the highest E naught. Someone raise their hands, you can go ahead.
Yes, sir. I was just asking you to repeat what you said the value is again. You said that it is the value to that shows how
Oh,
relative thickness and what's
their tendency to basically it is showing their tendency to gain an electron.
okay, sir.
Yeah. All right.
So did they give the value for thiosulfate?
Yes, they give it in the question. I here is for iodine. All right, let me just write it out. For chlorine, for fluorine, where we have most reactive, you can put strongest oxidizing agent. It is the most reactive of the halogens and the strongest oxidizing agent as well. So fluorine is the most reactive and the strongest because it has the highest E0, and iodine is the least reactive, the weakest oxidizing agent. This one was 4 marks. What is the formula for thiosulfate? I'm going to put it, look to the bottom right of the screen. That's the formula for sodium thiosulfate.